Greetings, fellow explorers of the grand cosmic ocean. I'm Analysis, and it's a profound pleasure to welcome you. We stand on the shores of the known, gazing out at an expanse so vast, so mysterious, it humbles us and ignites a fire of curiosity within our very being. The universe isn't just out there, it's in us. The iron in our blood, the calcium in our bones. These elements were forged in the hearts of stars, long ago and far away. Today we embark on a voyage not with a spaceship of the imagination, but with the vessel of knowledge, to uncover just a few of the universe's most astonishing truths. Prepare yourselves to have your cosmic perspectives gently, or perhaps radically, shifted. These aren't just disconnected pieces of trivia, they are windows into the fundamental workings of reality, clues in the grand detective story of existence. Each fact is a brushstroke on a canvas that stretches to infinity, revealing a picture more intricate and more beautiful than we could ever have conceived on our own. It's a reminder that the quest for understanding is a journey without end, but one filled with breathtaking vistas at every turn. Welcome to our channel. Today we're diving into the cosmos with 10 fun facts about space that will blow your mind. Don't forget to like, share, and subscribe for more amazing content. We're about to explore phenomena that defy earthly intuition, that stretch the limits of imagination, and that ultimately connect us more deeply to the universe we inhabit. So, buckle up your curiosity, and let's begin this exploration together. The cosmos awaits. Consider our sun, that familiar golden orb gracing our skies, the giver of life, the anchor of our solar system. We see it daily, perhaps taking its presence for granted. Yet to truly comprehend its scale is to invite a sense of profound awe. Imagine our home Earth with all its mountains, oceans, and continents. Now try to envision something over 300,000 times more massive. That is the measure of our sun. It doesn't just dwarf Earth, it utterly dominates it, a celestial titan holding us gently in its gravitational embrace. This immense mass is the engine of its power, the source of the light and heat that bathes our world. This staggering difference in mass dictates the very architecture of our solar system. The sun's gravitational field is a vast invisible hand, choreographing the dance of planets, asteroids, and comets. Its sheer size means it contains 99.86% of all the mass in our entire solar system. The remaining planets, including our own Earth, are mere cosmic dust motes by comparison. Understanding this scale isn't just about numbers, it's about appreciating the raw power and central importance of the star that makes our existence possible, a true behemoth in our cosmic neighborhood. It's a scale that challenges our everyday intuition. Imagine the loudest explosion you can conceive, a supernova perhaps, the cataclysmic death of a massive star. In the vacuum of space, this monumental event would unfold in utter, absolute silence. Why? Because sound, as we experience it, is a vibration, a wave traveling through a medium, air, water, even solids. Space, in its vast emptiness between celestial bodies, offers no such medium. It is a near-perfect vacuum. So despite the dramatic depictions in science fiction with roaring engines and laser blasts echoing through the void, the reality is far more serene and perhaps more unsettling. This cosmic silence is a profound characteristic of the universe beyond our atmospheric blanket. It speaks to the immense distances, the emptiness that separates stars and galaxies. There are no air molecules to jostle, no particles to carry the vibrations of a cosmic symphony or a cosmic cacophony. It's a silence that forces us to reevaluate our senses and how we perceive the universe. It underscores the preciousness of our own atmosphere, that thin layer of gas that not only allows us to breathe but also to hear the world around us. Out there, the universe communicates in other ways through light, gravity, and the silent dance of matter and energy. Let us turn our attention to Venus, often dubbed Earth's sister planet due to its similar size and composition. Yet, this sibling harbors a temporal peculiarity that defies our earthly understanding of days and years. Imagine a day, the time it takes for a planet to complete one full rotation on its axis, stretching out longer than the time it takes for that same planet to complete an entire orbit around its star, its year. This is the bizarre reality on Venus. A single Venusian day lasts approximately 243 Earth days, while its year, its journey around the Sun, takes only about 225 Earth days. This extraordinary phenomenon arises from Venus's incredibly slow retrograde rotation. It spins lazily on its axis, and in the opposite direction to most other planets in our solar system. Picture it, the sun would rise in the west and set in the east, and you would experience a sunrise, then an entire year would pass, before that same sun finally set. Such a leisurely spin cycle has profound implications for the planet's climate and geology, contributing to its runaway greenhouse effect and scorching surface temperatures. It's a world where our fundamental concepts of timekeeping are turned on their heads, a testament to the diverse ways planets can evolve. Chapter 4. Cosmic Abundance Stars Beyond the Sands. Gaze upon a handful of sand from any beach on Earth. Count the grains if you could, an immense number certainly. Now try to comprehend this. There are more stars in the observable universe than there are grains of sand on all the beaches in all the deserts across our entire planet. This isn't hyperbole, it's a carefully considered astronomical estimation. The sheer number is so vast it transcends our ability to truly internalize it. We speak of billions of stars in our Milky Way galaxy alone, and then we multiply that by the hundreds of billions, perhaps trillions of other galaxies spied by our telescopes. Each of those distant pinpricks of light is a sun. Many potentially with their own planetary systems, their own orbiting worlds. This staggering statistic isn't just a curiosity, it's an invitation to ponder our place in this immense cosmic tapestry. It recontextualizes our significance or perhaps our insignificance, depending on your philosophical leaning. But more than that, it opens up a universe of possibilities. With so many stars, so many potential cradles for planets, the chances for other forms of existence, other stories unfolding across the cosmos, become not just plausible, but perhaps inevitable. The universe is not sparse. It is overwhelmingly, wonderfully, full. Chapter 5, Solar Immensity, A Million Earths Within. We've touched upon the sun's mass, but let's now consider its volume, the sheer space it occupies. Our star the sun is so colossally large that if it were a hollow sphere, you could comfortably fit approximately 1.3 million planet Earths inside it. Imagine our world with all its diverse landscapes and sprawling civilizations, reduced to the size of a tiny marble. Now picture over 1 million of those marbles filling a gigantic celestial orb. This is the scale we're contemplating. It's a volume so immense that it's difficult to wrap our minds around using everyday comparisons. This incredible capacity is not just an abstract number, it's directly related to the sun's function as the powerhouse of our solar system. Within this vast volume, nuclear fusion reactions rage at its core, converting hydrogen into helium, and releasing an unimaginable amount of energy. This energy radiating outwards is what warms our planet, drives our weather, and fuels photosynthesis, the very basis of life as we know it. The sun's generous volume is a constant reminder of the stellar engine that sustains us, a sphere of incandescent plasma whose size is intimately linked to our existence. Chapter 6. Cosmic Spinners, the Dervishes of the Universe, Neutron Stars. When a truly massive star, far larger than our sun, exhausts its nuclear fuel, it collapses under its own immense gravity, and then explodes in a spectacular supernova. What can remain is one of the most exotic and extreme objects in the universe, a neutron star. These stellar remnants are incredibly dense. Imagine the mass of our sun, or even more, compressed into a sphere only about 20 kilometers or 12 miles in diameter, the size of a city. This compression has a dramatic effect on its rotation. Much like an ice skater pulling their arms in to spin faster, the collapsing star spins up. And faster is an understatement. Some neutron stars, particularly those known as pulsars, can rotate at astonishing speeds. We've observed neutron stars spinning hundreds of times every single second. Imagine an object more massive than the sun, yet only the size of a city, completing 600 full rotations in the time it takes you to blink. The forces involved are mind-boggling, the surface gravity immense. These are cosmic lighthouses, sweeping beams of radiation across the galaxy as they whirl, testament to the extreme physics that governs the end-of-life stages of massive stars. Chapter 7. A Diamond in the Sky, the Exoplanet 55 Cancri E. For millennia, humanity has gazed at the stars and wondered about other worlds. Today, thanks to sophisticated telescopes and detection methods, we know that exoplanets, planets orbiting stars beyond our sun, are not just common but ubiquitous. And among this diverse cosmic menagerie, we find worlds that challenge our imagination, worlds unlike anything in our own solar system. One such tantalizing candidate is a planet designated 55 Cancri e, orbiting a star some 40 light-years away. Scientists have gathered evidence suggesting this super-Earth might be a diamond planet. The theory posits that 55 Cancri e, being carbon-rich and subjected to immense pressures and temperatures due to its proximity to its star, could have a significant portion of its mass, perhaps even its entire mantle or crust, composed of crystalline carbon diamond. Imagine a world glittering with this precious material on a planetary scale. While we cannot yet send a probe to scratch its surface, the data from its density and atmospheric composition points towards this glittering possibility. It's a reminder that the universe is a laboratory of extreme chemistry and physics, capable of forging worlds of unimaginable composition and value. Chapter 8: Lunar Echoes, Footprints Frozen in Time. In July 1969, humanity achieved a monumental feat. We walked on another celestial body, our moon. The bootprints left behind by astronauts like Neil Armstrong and Buzz Aldrin in the lunar dust are more than just indentations, they are symbols of our reach, our ambition, our curiosity. But what is truly remarkable is their potential longevity. On Earth, footprints in the sand are quickly erased by wind or water. On the moon, however, there is no atmosphere to speak of, no wind to sculpt the surface, no rain to wash it clean. Because of this airless, weatherless environment, those historic footprints, along with discarded equipment and rover tracks, will remain remarkably preserved for an astonishingly long time. Barring direct meteorite impacts, scientists estimate they could persist for tens of millions, perhaps even up to 100 million years. Imagine, eons from now, long after all of us are gone, these silent testimonies to a fleeting human presence will still be etched onto the lunar landscape. They serve as a quiet, enduring monument to a pivotal moment in human history, a message to the future or perhaps to any other intelligence that might one day visit our silent satellite. Chapter 9: Cosmic Reservoir, a universe awash with water. Water, the quintessential ingredient for life as we know it. We search for it on Mars, on the moons of Jupiter and Saturn, believing its presence is a key indicator of habitability. But what if I told you that water exists in quantities that dwarf all the oceans of Earth, in some of the most unexpected places in the cosmos? Astronomers peering deep into the universe have discovered an enormous reservoir of water vapor surrounding a distant quasar, a supermassive black hole actively feeding on surrounding material, located over 12 billion light-years away. This colossal cloud of water vapor is estimated to contain at least 140 trillion times the amount of water in all of Earth's oceans combined. It's the largest, most distant reservoir of water ever detected in the universe. Its existence so early in cosmic history suggests that water has been abundant since the universe's youth. While this particular water is in gaseous form and not a sloshing ocean, its sheer scale tells us that the fundamental building blocks of life are not rare cosmic accidents, but are woven into the very fabric of the universe, present in vast quantities across immense stretches of space and time. Chapter 10: Martian Colossus, Olympus Mons, the solar system's giant volcano. When we think of colossal mountains, many of us picture Mount Everest, the highest peak on Earth. But even Everest is dwarfed by a volcanic giant on our neighboring planet, Mars. This is Olympus Mons, a shield volcano of such breathtaking proportions that it stands as the largest known volcano in our entire solar system. Towering approximately 13.6 miles or 22 kilometers high, it is nearly 3 times the height of Everest. Its base would cover an area roughly the size of the state of Arizona or the entire nation of France. How did such a monstrous volcano form on Mars? Several factors likely contributed. Mars has lower surface gravity than Earth, allowing mountains to grow taller before collapsing under their own weight. Furthermore, Mars is not believed to have active plate tectonics like Earth. On our planet, tectonic plates drift over volcanic hotspots, creating chains of smaller volcanoes. On Mars, the crust likely remains stationary over a persistent hotspot, allowing lava to accumulate in one location for an immense period, building Olympus Mons layer by layer into the behemoth we see today. It's a silent, rusty red monument to a geologically active Martian past. And so, our brief excursion through these 10 cosmic marvels comes to a close. But the journey of discovery, of course, never truly ends. From the almost incomprehensible scale of our sun and the number of stars in the cosmos, to the eerie silence of space and the bizarre temporal rhythms of Venus, each fact is a testament to the universe's boundless capacity to surprise and inspire awe. We've glimpsed diamond planets, ancient footprints on the moon, and colossal volcanoes on Mars, reminding us that reality is often far stranger and more magnificent than fiction. These glimpses are not merely intellectual curiosities. They are invitations. Invitations to look up at the night sky with a renewed sense of wonder, to ask questions, to seek understanding. The universe is constantly revealing its secrets to those who are patient and persistent enough to look and to listen with the tools of science. It's a grand narrative still being written, and each of us has the potential to appreciate its unfolding chapters. The desire to explore and understand is a deeply human trait, one that connects us across generations and cultures. Thanks for watching. If you enjoyed these fun facts about space, make sure to hit the like button, share with your friends, and subscribe to our channel for more fascinating videos. See you next time. Continue to be curious, continue to explore, because the cosmos is waiting, filled with wonders yet to be uncovered. Until our next journey together, keep your eyes on the stars.